Hi again. On page number 6 of lecture 1.2, there was a proof at the bottom of this page, page 6, but I had not filled it in yet. I was waiting to do it in another video. Let me grab a pen, that is always helpful. So on page 6, I'm going to go down and talk about a proof. If you have not taken Math 275, which is disco, then this may be the first time you're seeing a proof like this. Um, yeah, so this might be the first time you've ever encountered an element-wise proof. It's a way here to show that two events are the same. I mean, I can show easily, like in a picture, that A intersect B complement is the same as A complement union B complement. But when you want something stronger than a picture, you need a proof. And one way that we prove an expression is equal to an expression is through an element-wise method proof. And I thought I would go through this one because there's another one, the other direction in the homework. So I thought I would list out the points so you could kind of notice how the flow of this type of proof goes. And again, if you've not seen this before, it will be hard. And in the homework, if you want to ask me some questions or do a trial and send it to me, I realize that this is kind of a big jump if you've never seen a proof like this before. So I'm just going to go back to something we learned in the previous page. To show two events are equal, or two sets are equal, I need to show that A intersect B complement is a subset of A complement union B complement. But I also need to show then that this side is a subset of the left-hand side. So I'll just say that in words over here. So I need to show equality, I need to show two things. A intersect B complement is a subset of A complement union B complement. But number two, I also need to show A complement union B complement is a subset of A intersect B complement. Now I'm going to show you number one in this video. Number two is what you're doing in your homework, and it's going to follow very similarly to what I'm going to do right now. So we'll call this a proof because that's what we're doing. And you might wonder, sometimes it looks like I'm doing nothing, but I'm really doing a lot. It's really just a lot of symbol manipulation to say this means this means this. So you'll see what I mean. So to do an element-wise proof, remember, to show this is a subset of this, I should be able to take any element out of here, and we'll call that element X. If I take any X out of here, that X better be over here. So that's what I'm going to do. I'm going to choose an X out of this set and show that that X is in this set. So let X be an element of, so that's that symbol, let it be an element of A intersect B complement. Okay, so if it's an A intersect B complement, so in other words, let that be A and let that be B. Here's A intersect B right there. So if X is an element of A intersect B complement, then we know that X is not in A intersect B, right? I mean, because if it's in its complement, it's sitting out here or out here or out here, I know X is not an element of A and B. And if X is not an element of A and B, then we know thus X can't be in A or X can't be in B. If it's not in A intersect B, then either X is not in A or X is not in B, or both. It could be out here somewhere, but this takes care of it. X is not in A or X is not in B. So going back to symbols, this means X is an element of A complement, or X is an element of B complement. And you might notice then we're right where we want to be. That's exactly what this statement says. So if X is an element of A complement or B complement, then X is an element of I'm just going to put this back into symbols, B complement. So I've shown that I've taken any x out of the left-hand side, and I've shown it's in the right-hand side. And this is a nice math word, hence, we have shown that A intersect B complement is a subset of A complement union B complement. And little box, I'm done. Some people put QED. It's Latin, though in our math classes we always said quite easily done, even though we never felt that way. And so there's an element-wise proof. Again, it's one of the, it's probably number 5 or 6 in homework set number 1. Feel free to ask me if you have any questions about this, or if you want to see, or if you want help with the one in the homework. So I'll sign off for now.